Hi, welcome to our PBL project assignment for microprocessor subject, and we are from group 14, and our lecturer's name is Dr. Muhammad Zaini bin Hashim. So, our group members consist of 3 person. My name is SYAZANI Hafizy bin Muhammad SYAHRULNIZAM, and the second one is AVINANDHA anak lelaki RAMACHANDRA, and the third one is VISHAL. And again, welcome to our presentation on the development of an automated animal milk feeder for modern dairy farming. So, this innovative system is designed to streamline the feeding process, improve efficiency, and enhance animal welfare. So, the key feature in this project is precision delivery. The system delivers measured quantities of milk at scheduled intervals, and it operates across the feeding lanes, ensuring timely and accurate feeding. And secondly, automation for efficiency. By automating the feeding process, the system guarantees precision and reduce human intervention. Basically, our project leveraged a microprocessor program using the Easy60K platform, enabling digital timers to manage feeding schedule effectively. Secondly, actuators for precise milk dispensing, ensuring no waste. And thirdly, sensor to detect the feeding needs of the animal in real time. So, for overall conclusion, basically this automatic milk feeder offers a groundbreaking solution to modernize dairy farming. It enhances the animal welfare, optimize feeding schedules, and boost productivity, paving the way for efficient and sustainability for dairy management system. Next, we move to problem statement. So basically, we get the idea for this project is from the research that we made. So, in the research that we made, we encounter that a few problems that give us idea to do this project. So, the first one problem statement that we identify is time and effort. So basically, manual feeding is very labor intensive, especially for a large herds, so many cows and cows. So the automated feeders save time and reduce physical work. Secondly, inconsistent feeding. Irregular feeding schedule and methods can harm calf growth and health. So this automation ensure accurate and regular feeding. Thirdly, hygiene issue. Manual cleaning can spread disease, so automated feeders maintain cleanliness by regularly cleaning feeding equipment. And lastly, monitoring problems. It's hard to track individual calf feeding and help manually. So, with the help of microprocessor, we use automated system to provide data to the monitor and manage calf. The problem statement that we just talked about, we already set our objective for this project. The objective of this automation milk feeder system is to ensure precise milk dispensing based on specific requirement, integrate sensor to automated feeding cycle, and detect the presence of cows, and establish feeding schedule tailored to the needs of each lane. Then that, me and my groomers also realized that we also need a high knowledge in microprocessor to make sure that this project is successful. In this project, we require skills in I/O interfacing, timing mechanism, interrupt handling, and basic electronics. It is very crucial for integrating sensor and actuator. The key of this project also requires the knowledge of microprocessor in terms of architecture, programming, and interfacing. This skill is combined that enable us to create a scalable, reliable, and efficient automatic milk feeder system.
My name is AVINANDHA RAMACHANDRA and my matrix number is BO122101157. Okay, so I'm going to continue my presentation and my part I will start from proposed solution. Okay, first is objective. Its main objective is milk preparation and dispensing for a group of calves. Okay, it's very effectively automate the preparation and dispensing the milk for group of calves which is in a small or medium-sized farms. Okay, the system, let's see about system features. It's managed by an EZ68K CPU, controls temperature, mixing ratios, and feeding schedules. Okay, it's really important because um, it's guarantee regular feeding, improves calves health, and minimize manual labor, and also automatic automating crucial problems for farmers. Okay, oh sorry. Okay, hardware components is temperature sensor, heater, solenoid valves, basic user interface with a keypad and display. Okay, these components are also important to avoid temperature or scheduling conflicts. And in interface part, we must make sure that it's uh, easy to use for the farmers or the calves owners lah. Okay, let's see about the process. User inputs feeding schedules and quantities. System blends water and milk replacer precisely, maintaining the correct temperature. Milk is dispensed at set times via solenoid valves for accurate dosing and even distributions. Okay, see, it's an automatic process, so it is really minimized and will save the labor's working time. Okay, error and handling is alerts for issues like low temperature or scheduling conflicts.
I am Vishal. My metric number is B01221011. Okay, now I'm going to explain about the target audience for our project, which is automation milk feeders for cows. Okay, the target audience are small to medium-sized farms using group feeding. So our project can apply to any farm, any size of farms that consists of calves. Okay, the benefits are economical and labor efficient because our project is fully automated, so there will be no need of any workers to see the operation. Second benefit ensures consistent feeding and better calf health. So because the automation milk feeder, uh, anytime the cows can drink, can get the milk from our machine, so it can also help for the calf health. The third one is simplifies operation by automating key tasks. This can be said because our project is fully automated. When the calves reach the lane, it can get the milk from the machine automatically. So there's no need of any other complicated work to be done. Okay, next I will be explaining the coding and the simulation. Okay, this is the coding that I use for our PBL project. Okay, first is original $1000, which is the starting address of the code that contain the memory 1000. Okay, then the switch one coding is to read the status of the switch from memory location into register DO. Okay, the BQ reset is if switch 0 is not triggered, the program jumps to the reset label. Okay, then I will explain about the lane coding. We have 7 lanes. Okay, 7 lanes. Okay, the first is the first coding, which is move p $sign hashtag $06 $e 0000e. It will activates the LED, so the display in 7 segment for number one. The second is move p hashtag $02 $E00010. It will read the switch status again, and then it will check switch 1 in D0. The PTSD hashtag 1D0 is if the switch 1 will be activated. Okay, then the next one is PHI lane 2. So if the switch is toggled to logic 1, it will skip to lane 1, meaning the lane 1 will be not providing milk for the cows. JSR switch 2 is it will jump to subroutine switch 2. Okay, this will apply to all the lane until lane 1 to from lane 1 to lane 7. Okay, the timer. Okay, we set the time for 1000 millisecond. So it will the use of the timer is to set time to start giving milk to calves again. Okay, it will display 0 on the 7 segment display. Okay, okay, now I will show the demo. Sorry. Okay, so now the switch is 0. Okay, when I toggle this to 1, so all the lane will providing milk for the calves. So as you can see, the time is 1000 millisecond. Okay, okay. When I toggle switch 2 and switch 5, so only lane 1, lane 3, lane 4, lane 6 and lane 7 will be providing milk for the cows. Okay, okay, when I switch the lane 6, 7 to 1, meaning only lane 1 and 1, 3, 4 will be providing milk to the for the calves. Okay, when I reset, okay, the reset part will be explained by my friend. Okay, only this from me. Thank you.
So then next part is reset. Reset is like first it will activates LED 0. It's clear multiple memory location and resets all the display in the 7 segment. Lastly, loops back to switch 1. Okay, switch 2. Switch 2 is first it will read the switches. If switch O is off, it jumps back to switch 1. The process is continuous to delay. Okay, subroutine delay 1. First, it's decrement the counter until reaches 0. Turns off LED after the delay. See here, it shows that turns off the LED first before continuing the program. So it will turns off after the delay. And then delay 2, it seems like same like delay 1, but with larger counter values. Gives delay for timer and jumps. Finally, it ends by jumping the entire program back to switch 1. So that's the whole process in this simulation. Okay, that's it with our slide. So this is what we have done for our assignment for microprocessor, for the course microprocessor. Okay, thank you.